Okay, so in this topic, we're going to learn pretty much the last way to solve systems of equations. This one actually is my preferred way because it's most like solving a puzzle. So far we solved systems using graphing and substitution. These notes show how to solve the system algebraically using elimination, which is the new method, by addition or this other way of multiplication, then addition. Elimination essentially gets you to eliminate one of the variables to solve for the other and then plug it back in. The best method, this is the best method used for standard form. So it's a reminder here, what's standard form? Well, you should remember that it's ax plus by equals c, as we've seen in the previous chapter. Okay. Here's the process, in which you'll see some examples done out right after. You got to put the equations in standard form if they're not already. Okay, so generally you'll have the choice as to how to, which method you'd want to use. So if they're not in standard form, you may not use elimination. But in this case, we have to start with standard form. Determine which variable to eliminate. All right, so relatively, you're going to look for variables that have opposite coefficients. So if you see a negative 2x on the top equation and a positive 2x on the bottom equations, that would be the one you want to go with. So if you add, which variables would zero out, essentially? Depending on the situation, you're going to add or multiply by -1 and then add the equations. So essentially, you're going to be adding or, in essence, subtracting to get rid of one of those variables. You solve for it. So kind of like substitution, we're going to plug back in one of our answers into the other variable in one of the equations. And then, as always, check our solutions to both equations. Here's our first example. Okay, I'm identifying variables that have coefficients that look like they're opposites. So we're going to be adding here. I see my y's. I have a plus y and a minus y. All right, so kind of like you guys did way back when we were adding two things together. We draw our plus, we draw a line. I'm going to add them together. X plus 3x is 4x's. Plus y minus y cancel. And then equal sign, 5 plus 7 is 12. We're left with a one-step equation that we can now solve for x. X is 3. All right, we're halfway done. I can now plug my 3 into one of the two equations to solve for the other variable. I'm going to choose the first one. So we have, instead of x plus y is 5, 3 plus y is 5. Therefore, y is 2. All right, so now we're just going to test our answer of 3, 2. Plugging it into the top one, I get 3 plus 2 equals 5. Check. Plugging it into the bottom one, I get 3 times 3 minus 2 equals 7. Also works. So this is a pretty quick process. All right, next example. Sometimes you're going to run into a scenario where you want to multiply by -1 first and then add it. This is essentially the same as subtracting. So I guess we could think of it both ways. You notice the 2x's here, they're both positive. So if I multiply this by a negative first, I'm essentially rewriting everything. I'm going to just copy down the first equation and just change the sign of everything down here. Oops, make that a plus. So as you can see, I pretty much just altered the bottom equation. Now when I add it together, the x's cancel. I get a 4y and a positive 8. So I can divide by 4 to get y equals 2. And then the process repeats itself. We're going to plug y in this time. I'm going to plug it into this equation on the top. 2x plus 2 equals 4. Subtract the 2. Divide by 2. And we get 1, 2 for our solution. We can verify it, as you always should. 2 times 1 plus 2 equals 4. Plugging it into the top one. Check. And now when you test for the bottom, you can plug it back into the original. So that's going to be 2 times 1 minus 3 times 2 equals -4. That's 2 minus 6. Yes, that also works. So in this sense, we have solved this system. Okay, one more example before I have you guys try this out. Sometimes they're not lined up. So you may have to line it up first. Put it in standard form officially. So the first one I'm just going to rewrite. The 2x is fine. I'm going to bump the y over to the left by adding it over and then I'm going to just rewrite the bottom one so everything's nice and lined up. You'll be able to see things easier. All right, as you can see here, I have two positive y's, so I'm going to do the whole minus trick here. You may have to rewrite your system a couple times to set everything up, but that's okay. Negative 4x minus y equals negative 5. All right, so add those things up. Negative 2x, the y's cancel. 7 plus negative 5, well, that's 2. So therefore, dividing by negative 2 gives me x is negative 1. I'm going to take that answer, plug it into the first equation. 2 times negative 1 equals 7 minus y. Okay, so I'm just going to solve this a little bit. I'm going to subtract the 7 over, so I get negative y equals negative 9, which means positive y is 9. So I'm going to check my solution of negative 1, 9 into both equations. Make sure I'm good. 2 times negative 1 equals 7 minus 9. Check. 4 times negative 1 plus 9 equals 5. Check. There's my solution. Okay. You guys can now try both examples. Make sure you're setting it up and you're lining things up and doing what you need to do to get it to cancel using any of the techniques I described above.